trying to solve one-step equations. But before we do that, let's review how to write inequalities. Traveling salespeople for a book company are paid at least $250 for each trip they take to sell books. Write and graph an inequality to describe the amount salespeople are paid per trip. At least $250. What does that mean? That means $250 is the least amount they will get. That means they will get paid more dollars than $250. So here's $250. They will get paid at least. I mean, they're going to get paid $250, but then they'll get paid more than that because this is the least they will get paid. So we're going to shade everything here. How would we write this as an inequality? Well, with X is any amount. They're going to be paid at least. That means at least mean, or is it more than? Are we paid more than or greater than? Or equal to 250, and that is our inequality. Because they are paid an amount that is more than 250, or they are paid an amount that is more than and equal to 250. This means at least. They're paid at least 250. 250 is the least amount they'll get paid. So again, in case you are still having issues with inequalities, you have inequality compare quantities. So we have different examples. We have less than, which is fewer than. We have greater than and more than. We have less than or equal to or at most. And we have greater than or equal to or at least. Go back to the last presentation, last YouTube video, or write inequalities and represent solutions if you're having a little difficulty which one is which. So, how do you solve inequality or inequalities? So our aim is to have x, or whatever the variable is, which is a symbol, on its own on the left of the inequality sign. Something like this. Do you see how the variable or symbol or letter is on the left-hand side? X is less than 5. Y is greater than or equal to 11. We call that being solved. So, for example, if you ever see the problem written like this way, 5 is less than x. Could you write it like this way? X is greater than 5. As you see, what I did is I moved the x to the left of the inequality sign, and I flipped the sign over. Would this work? Name a number that is greater than 5. 6. Is 5 less than 6? It is. But is 6 greater than 5? It is. So it means the exact same thing. But I think in 6th grade we deal where the variable is always going to be on the left-hand side. So solving inequality is very like solving equation. We do most of the same thing, but we also pay attention to the direction of the inequality. In elementary school, you learn that the bigger numbers is facing the inequality, while the small numbers are facing against the inequality. For example, I know when I taught elementary school, I told the kids to say, draw 2 dots for the bigger number. Draw 1 dot for the smaller number. Direction is which way the arrow points. So for example, the direction, again, if you look at this arrow say you draw the shade to the right because the arrow is pointing. There are things we can do without affecting direction and inequality. When you add or subtract a number from both sides, you leave the inequality alone. When you multiply both sides by a positive numbers, you leave the inequality sign alone. Then you simplify a side. In our next YouTube video, we're going to learn what happens when you have to flip the sign over. In what instance? So before that, let's see what you remember about how to graph inequality. A number is greater than 2. So find 2. I draw a circle. Is it going to be an open dot or a closed dot? Am I including 2 here? No, it is an open dot because I'm not including 2. Can you name numbers that are greater than 2? 3 is greater than 2, 4 is greater than 2, 5 is greater. So I'm shading to the right. Hint, look at this arrow. What direction is it facing? It's facing to the right. That's why we shade to the right. That's what I learned from my high school teacher when I learned this as a kid. It's like, I always ask, I don't understand. How do you always know, do you shade it to the right or do you shade it left? Oh, I got so confused. So she said, all right, Sam, as a shortcut, do you see how this arrow is pointing to the direction of the right-hand side? I said, oh my God, that's so easy. Next one. A number is greater than or equal to 1. So find 1. Is it going to be an open dot or closed dot? A closed dot because you are including 1. 1 is part of the answer. So name some numbers that are greater than 1 or equal to 1. 2, 3. So it will be facing or shading the direction to the right. Again, how do you know? Do you see how this arrow, the direction is facing to the right-hand side? Next one, number 3. Find 3. Is it going to be open dot or closed dot? Open dot because there's no equal to here. So a number is less than 3. Is 2 less than 3? Yes. All of these are less than 3, so I shade to the left. Again, how do I know? Do you see how this arrow is facing to the left? Next one. Find 6. Open dot or closed dot? Closed dot because it has an equal to here. A number is less than 6. 5 is less than 6. 4 is less than 6. 3 is less than 6. 2 is less than 6. So I shade to the left-hand side. Now that we remember how to shade in and now we know how to graph inequality, it is time to solve an inequality. So let's do an investigation. At what instant will a plus 2 will be greater than 0? So I wrote out all kinds of things. We're going to find true or false. If I substitute or plug in the a with negative 5, negative 5 plus 2 is negative 3. Is negative 3 greater than 0? False. If I substitute a with negative 4, is negative 4 plus 2 is negative 2? Is that bigger than 0? Of course not. False. If I plug in negative 3, is negative 3 plus 2, that's negative 1. Is negative 1 greater than 0? I don't think so. False. If I plug in negative 2 plus 2, that's 0. Is 0 greater than 0? No. It's equal to, but it's not greater. If I plug in negative 1 plus 2, that's 1. Is 1 greater than 0? It is. If I plug in 0, 0 plus 2 is 2. Is 2 greater than 0? It is. So all of these will be true. Why? 5 plus 2 is 7, which is greater than 0. So let's go look at our graph now. Oh, goodness gracious. How am I going to do this? Anyway, so let's see. True is negative 1 to 5. So here's our graph. So the true was, oh goodness, cannot remember what it was. It was negative 1, 0, 1, 2, 3, 4, 5. All those were true statements. They all had a T circle to it. The equation again was A plus 2 is greater than 0. Why is it this way? So this is one way you can do it. Now it's time to solve it. This is almost like an equation, except it has an inequality. If you put an equal sign, I know you could have solved this. All right, what do you remember? This is an A. Mr. A, he wants to be kept by himself. It's a variable. I need to get rid of plus 2. What is the inverse operation of plus 2? Subtract 2. So subtract 2. Subtract 2. These two cancel out. What do you have when you have 0 with negative 2? Negative 2. So A is greater than negative 2. So I go to negative 2. I circle it. Is it an open dot or closed dot? It is an open dot because they're not including it. And do you see how all these were true? I shade to the right. And from here, I shade to the right. So what I did is I solved for A, and then I graphed the inequality. Let's try another example. Let's make it better, this one. So, right here. 5m is less than or equal to 10. Let's raise this up a little higher. In which instant is this true? So we're going to circle true and false statement. Is 5 groups of negative 5, that's negative 5, negative 25, is that less than 10? That's true. Is 5 groups of negative 4, that's negative 20, is that less than 10? It's true. 5 groups of negative 3 is negative 15, less than 10. 5 groups of -2 is -10, less than 10. 5 groups of -1 is -5, that's less than 10. 5 groups of 0 is 0, that's less than or equal to 10. 5 groups of 1 is less than or equal to 10. 5 groups of 2 is 10, which is less than or equal to 10. Now, what's 5 groups of 3 is 15. That is not less than or equal to 10. 5 groups of 4 is 20. Remember, I'm substituting the m with the 4. 5 groups of 4 is 20. That is not and not. So which numbers do I circle? From -5 all the way to 2. All of these are true statements. So let's solve this now and see why these are true statements. Because I know you don't want to sit here and go through every single situation. You could. You can plug in every single number into the number line into the variable. I'm not. That takes way too long. So I need to solve for m. What operation is 5m? 5 times m or 5 groups of m. What operation is the inverse of it? Divide by 5. Divide by 5. So 5 divided by 5 is 1m. 10 divided by 5 is 2. So it's m is less than or equal to 2. So go to 2, draw a circle, a dot. Is this an open dot or closed dot? This is a closed dot because you are including 2. Plus, isn't 2 a true statement? So where are you facing? To the left. And as you can tell, aren't all these circled right here? So all these are true statements. So let's go to a couple of examples now. Solve each inequality, represent the solution on the number lines. So let's do our first example. A plus at what instant will A add to 4, which is less than 10, will you be able to graph it? Let's solve it. So solve for A. What operation is the opposite of plus 4? Minus 4. Minus 4. Cancel. 10 with -4 is 6. A is less than 6. So I graph 6, 7, 8, 5, and 4. So I do 2 integers to the right of 6, 2 integers to the left of 6. Now, is this an open dot or closed dot? An open dot is which numbers that I graph are less than 6, 5 and 4. So I shade it this way. But if you do not want to overthink that way, it's the direction of this inequality is to the left. Next one. G take away 11 is greater than 2. What operation is the inverse of minus 11? Plus 11. Plus 11. This cancel. 2 plus 11 is 13. G is greater than 13. So let's graph this. This is 13. What are the 2 integers to the right of it? 14, 15. What are the 2 integers to the left of it? 11 and 12. So I go to 13. It's an open dot because this is greater than or less than open dots. Which numbers or integers are greater than 13? Well, 14 and 15 are. So it is facing to the right. Again, let's look at this inequality arrow. It's facing to the right. 3 groups of t is less than or equal to 15. What will t equal to? What operation is the opposite of divide? Divide by 3, divide by 3. So t is less than or equal to 5. So let's graph this 5, 6, 7, 4, and 3. Is 5 going to be a closed dot or open dot? A closed dot because including equal to. And which numbers that I write down are less than 5? 4 and 3. So face this way and look at the arrow, face to the left. Next one. There's my arrow. Next one. Here it is. So next one, f divided by 5 is greater than or equal to 8. At what instant, what will f be so it can be greater than or equal to 8? What's the inverse operation of divide 5? Times 5 times 5. So this cancels. F is greater than or equal to 40. So we have 40, 41, 42. What are 2 numbers that precede 40? 38 and 39. So 40 is a closed dot. The arrow faces to the right because 41 and 42 are greater than 40 or this way. And so the main thing we talk about here is how to graph inequality and solve inequality. If you are given an inequality like, I don't know, a plus, let's make it hard. A take away 3 is greater than 6. You solve for the variable. So I want A. I want to solve for this. So what you find the inverse operation of minus 3 plus 3 plus 3. That's 9. So A has to be greater than 9. Then you will create a number line, and then you will graph it. So again, if the symbols are less than or greater than, it will be an open dot. If it has a line below it, which would mean equal to, you have to be a closed dot because you're including that number. So this is an open dot. Which one of the numbers, integers that I write down, are greater than 9, 10, and 11? That's one way you can do it. You can do examples and keep on plugging it in or substitute until we see which one are true statements. Or, as my high school teacher told me, it's facing to the right, so that's why I have the shade to the right.